the evolution of VIG to where it is today is the biggest change, because you can't get anywhere near the U values and R values that you get with VIG with any other product that's made today.
Welcome, Rob. Bob.
Thanks.
Thanks for coming on. And I was thinking about what would be the most interesting topic to talk about. And before we get into specific companies and names, I think a good theme here might be the challenges of bringing new technologies to market, and specifically to your experience. You have
that'd be great. I would like to avoid branding, if at all possible, other than generalities.
That's good, and I appreciate that. And that's because I try to make this podcast really kind of brand agnostic, and really get to the root of the realities of our industry and the challenges. But it's perfect that you just said that, because I wanted to talk about VIG, and more so really electrochromic.
Okay. Well, it's interesting, by the way. I believe yesterday my current clients were in visiting your former employer.
That is interesting. And I'm looking at a project outside of my window right now that might be specific to who you're speaking of. But that's interesting. And really, I'm working with another that I'm not going to name names either, but that is working with your ex partner in that engagement, and still seeing it out there. So
it's real. And I'll let you kind of lead from this point forward, where you'd like to go. I'm still a huge believer in the evolving technologies that exist. So by all means, I'll let you kind of direct this how you'd like it to go, and I'm more than happy to give you some opinions. And when I don't have one, I will tell you that. And when I don't feel qualified to answer the question, I'll tell you that too.
You're more qualified than you think, and that is usually when people are humble. It usually means they're wiser than they give themselves credit for. So with that said, okay, so even today with proven technologies, let's look at VIG, let's look at electrochromic, however you want to classify this. Before we get really specific into the product, there is a reluctance in our industry to jump onto quote unquote what people think are new technologies, and what perception is not always reality. So although they might think, well, we don't see this in this market, and well, we're in Seattle and we get a lot of rain here, so even though it works in Chicago, I don't know if it's going to work here.
Right.
You get a lot of that going on. Does that excite you? A little bit of it is nonsense, but does it excite you, like being sort of indifferent and a subject matter expert coming in and helping overcome some of those limiting beliefs?
I think so. In my career, I've enjoyed the opportunity to work with some pretty bright people and be involved in some really interesting technology as it evolved. And I mean everywhere from 45 years ago or 48 years ago, when Low E was first coming into market, and had an opportunity to be with a company that was an early adopter of using it, and did a lot of it. And there were issues with that when it started, and you look at where it is today, and it's become status quo. I mean, there's just nothing that goes anymore that doesn't have some sort of a low emissivity coating on it, whether it be the real high end triple silvers and things like that, all the way down to just your basic, standard single coat products. So yeah, I do enjoy it. The interesting thing about it, and if you think specifically about electrochromic, the true electrochromics, regardless of who was doing it, added the element of low voltage into curtain walls and window wall systems. And the idea of having to wire, if you will, a live wire these buildings and get to the software connections, because they are all the major ones were all predictive and were all software driven with the ability to override them. So that was kind of cool. I mean, in all honesty, being on the front end or early end of that, it was pretty interesting to look at how you have to integrate that kind of product into existing systems. Whereas if you can design one from a ground up standpoint that's meant for use with one of those smart glasses, it creates a simpler path and process. So that's fun.
It's funny you say that because I was maybe not humbled recently, but I was in a Boston glazing contractor's office recently, and he's like, the stuff you post is like pretty basic. And I'm like, but he's like, but it's really good and it's informative. And I have to explain to somebody what is an IGU and what is seal and adhesion, testing and blah, blah, blah. But
oh yeah, you talk about a butterfly test and people go, huh?
yeah, I mean, right, right. And they don't know what a snap test is. But and I started to realize like we're doing pretty basic stuff here. It's just, the implementation, it'll never be perfected, but let's get as close to perfection as possible. But there's very really little true innovation in our industry. And watching you just speak, it made me realize like you're getting the chance to be at the cutting edge of new technology. And maybe 30 years ago when you were seeing unitized curtain wall become common practice, like that was cool. Where today, great, I'm doing a unitized curve wall job, and then your generation's like, congratulations, kid, like we've been doing this forever.
Well, there's some of that. There's some of that, but like you said, even unitized, when you think about it, you go back 30 years when it was first hitting the marketplace, and you look at the people that were doing it. There was a handful of guys, the Permastelises and people, Harmon, and people at the very upper end of the realm of the glazing contractors. And now you have guys that are regional, that have designed their own systems, and it doesn't need to be 100,000 square feet. I mean, I've seen unitized on jobs as small as 5,000 and 6,000 square feet, just because it was the best way to address putting the facade on that building.
I'm bidding a 45,000 square foot unitized job right now, and you get into this realm of 30 to 70, these guys are going to go after it. Under 30, these guys. Over 80, you're going to attract these guys in this part of the world. So it's like so much competition now that you need to just keep going into further and further subsets to identify who's going to chase after what.
Well, absolute truths.
And it's funny, what's hilarious is the first podcast I ever did actually happened to be with Scott at Luxwall. Funny enough.
Really?
And then the second podcast, now that I think about it, was Nick Bagatello's, and he was talking to me about when he first introduced, when California code basically governed that low E would be on everything. So when you were just speaking now, that's what I.
Well, and it's funny because they were together 4 years ago, and both great guys. I'm highly, I speak very highly of both of them. They are just exceedingly intelligent guys who led innovation in terms of, and especially in terms of utilization of vacuum. So you look at that, and I love that I've had the opportunities in my life to be around people like that.
Well, yeah, and Nick's whole thing was always like innovation, but I don't know if it was him, and I don't want to steal this from somebody else, but it really clicked. Might have been Mick Patterson, part of it, when it was like, well, half of innovation is adoption. And so you could have the coolest product in the world, but if people are afraid of it, see it as too risky, it's too expensive, you don't have the effective supply chain implementation, you're going to always have limitations. So what was let's start with, what was the first time you got exposure to electrochromic, and what was the aha moment for you?
The first time I got exposed to electrochromic was actually about 2015, and I had a client of mine ask me what I knew about it, and I said, I'll tell you everything I know about it in one sentence. It needs electricity. That's about what I knew at that stage. I understood the idea, and I understood the idea of moving ions and all of the chemistry and the components of it, but I had no idea how it's done. And I'm not a chemist. I'm not a material scientist. I'm a construction guy by training. But I had a client who was considering utilizing it. And so I said, all right, let me do
it. Let me interrupt. At that time, was it, could you go to commercial projects and see it, or was it like a science fiction thing?
It was there were very limited commercial applications of it out there. The three guys that were kind of leading that way back then, View, Sage, and Halio, they all had a little bit of work done by then. It wasn't like it was not happening, but it was somewhat limited in scope. And again, as you said, takes a while for adoption to hit. All three of them had been working on the tech for quite a while. So that's what I did is I started interviewing people who had used it and the suppliers themselves to try to figure out how they were bringing it to market and what my big issue was. As I was investigating it for a client, was you got to kind of get to the reliability, the warrantability, all of those durability issues that could create a financial burden if you adopted it and it failed. So that's where I was doing my homework. And at the time I said, like I said, I knew the basics, but from that point forward, it became doing a deep dive, and the technologies were varied and broad. Electrifying glass is nothing new. I had done some electrified privacy glass in Fort Lauderdale back in the mid 90s, where it went from clear to obscure. And people think it's backwards, but when you put the charge on it, it goes clear. When you took the charge away, it went to opaque. But that was a very different product than what electrochromic glass was, and especially the ones that were now eliminating glare and reducing solar heat gain, and that were predictive as opposed to reactive. And that was kind of the turning point in my mind. So when you say what's the aha moment, it was discovering that with the ability to use global positioning and the axis of the planet and the rotations, you could anticipate when it needed to tint as opposed to when you wanted it more on the clear side. And for me, that became a huge game changer as I looked at it and thought about what was the real sophistication of this product.
If you think about the elevator pitch, if you talk to a developer, facade consultant, architect, GC, or a random person renting a building or buying a condo, is it perform like, there's the performance implications. Obviously, you can mitigate solar heat gain. There's a comfort element. Or is it, the get rid of the blinds, which, and there's all these different elements, but like, what's the real, like, oh, wow, we have something here.
So for me, if I was asked that question, it's the ability to eliminate vision control devices, whether they be sunshades on the exterior or window blinds on the interior. I think that the clean, easy, low maintenance aspect to it is absolutely the most critical element, and the predictive aspect to it. So if I was asked by a condo person, for instance, I would say, well, the really cool thing is you can go to bed and you can look out at the stars, but before you wake up, it can be programmed, or it will tint down so the sun doesn't come in and wake you up.
I try to, so my wife has no grasp of facades or performance or nothing from this industry. So when I try to explain this stuff, and that makes sense, but we live in our first window wall building, and so it's Muse and this, it's all great, but she I wear an eye mask because I like it dark. She doesn't like to wear that, so I had to put the shades down every time. The blinds. And I think that would be the like, oh wow type of moment, and that would be the maybe we'd pay 3% more rent, 4% more rent to have that feature. So I think talking to, when you get on this side of the business, you get to have more of those open conversations with developers and be like, where do you really want to spend your money? Do you need this? You need to, this guy's coding instead of this guy's coding, or do you want to spend that extra money to have natural ventilation, or to have this, technological feature that you can market to your tenants, that I do think people would pay more for.
Well, there's data that supports that answer you just said. They will, in fact, both on the commercial side and the residential side, The lease rates for commercial space, for office space, goes up when the comfort level for the employee or the occupant is better. They're willing to pay more for it. A lot of buildings, if you recall going back, let's say 10 years ago, all of a sudden it became, we've got to add all these amenities. Or if you look at what WeWorks was doing, where they were adding that common space with the common kitchen, and it created an opportunity for sole entrepreneurs to have decent space with a lot of features. But the reality is, when you look at every single one of those developers and or those marketers, they will tell you those amenities are great, but if you can create a better, more comfortable environment inside the building, people will pay for it. And that more constant, no glare, no heat fluctuation, no degradation, or reducing UV degradation, and all of these things that come into play on a long-term lease.
Yeah, and I'm sure you got to experience it to really grasp it, right?
Absolutely.
We could talk about it all day long. I'll flash pictures on the screen, but it doesn't really mean anything.
No, you got to be in
stayed
it.
at the is it the Wave in Orlando, in Lake Nona?
Yeah, Lake Nona. Yeah.
Stayed there 3 or 4 times. It's very cool to be able to actualize that benefit in obviously an environment or climate like Florida.
Yeah, absolutely.
Obviously a contractor I used to work with did a run of these office buildings in Midtown East.
Yep.
Handel has that residential tower in Long Island City, right?
Yes, yes.
So where have you experienced it, or got to see it for yourself and really feel it?
Well,
Everywhere, I'm guessing.
There's a condo in Virginia that one of my clients actually used it as a sales tool, and I've spent multiple times in that unit and played with it both manually and allowed it to run per the predictive software. I wanted, again, being inquisitive and feeling like in order to be a subject matter expert, I should really grasp it. So I had it there. I've been in several of the buildings in New York, including the Nuveen project that you guys did, or that your former company did. Was in there quite a few times, in fact. So, from an electrochromic standpoint, I've been around a lot of it. I've also been in some thermochromic buildings, which is a non-electrified, it's a reactive product. It's different. It's interesting, but it's certainly not at the same level as the electrochromics are.
What do you think is just in terms of building typology, the easiest sell? And we really didn't cover this one, but airports seems like a no-brainer.
Well, the airports have become a big market for all of the electrochromic suppliers. And there are, I'm going to guess right now, but I would say there is electrochromic in probably 75 to 100 airports here in the US, in some portion, in some concourse, in some area of the building. There were some lounges, the traveler lounges that were done at multiple locations. You're at LaGuardia. There's that most recent redo. One of the terminals and the drop-off area was done with electrochromic. So in terms of adoption, they may be the largest adopter if you look at it as a market segment. And then I think from that point on, the easiest place, in my opinion, to get it is into healthcare and life sciences. But it doesn't always happen.
How efficient, or would you say predictable, is the sort of proactive element of the software in being able to moderate itself depending on the time of day and climate?
Well, again, I'll go back to what you asked earlier. For me, that is the aha. It is. And if it
so
is,
you think it's great? You think it's
I think it has the ability to be great. I don't know that it always is great, because things can affect it. If you've done your geo positioning correctly, and if your software is running glitch free, and again, whenever you have software involved, there's that big glitch free idea of it. They all glitch from time to time, but I think for the most part, the products are stable. They are they do a pretty decent job. The predictability of it, I think, is way better than I initially thought it would be. So if you were to ask me, is this going to be the be all end all do all? It at the time, it is very close to that. It does not increase the R value / U values, or decrease the U value or increase the R value as much as needs to occur. And
why is that? In a triple glazed element with whatever. We don't need to get into triple glazing versus double glazing, but the reality is, I'm going to Seattle next week for Facades Plus and participating there, and I'm sure I'll hear about what's happening at the most innovative projects given their stretch energy code. And then Boston, you see a lot of triple glazing, but I'm in New York and there's barely any of it. So I don't know if I don't know.
Well, so here's the issue. So the why is a simple answer. You can only achieve so much with low E coatings, even in combination with electrochromic. It doesn't get you. I can't get the U values that can be achieved, like say with a dual skin or with I mean, if you went to.
But let me, the root of what I'm thinking, and then you could steer the response towards that, because I want to press it, because I think this is an important topic. I don't think we need double skin facades. I don't think we need VIG to get us to where we need to be, is what I'm getting at. I think there's too much thermal loss through spandrel areas and interface conditions and poor detailing. I think what I'm getting at is I think we can achieve incredibly high performing facades with 40 to 60% window area incorporating electrochromic.
Respectfully disagree. And it's because I've watched the models that have been done on these buildings, and any way you look at it, in order to truly decarbonize and reduce energy consumption, we have got to, whatever is existing or whatever we do that's new, we've got to reduce the U factors, the U values and U factors on these buildings at that portion of the wall, because in many cases you can't do anything else to the other parts of the wall. So if you're looking at the total area of the skin of a building, and if the window area is 40%, let's say, and it's functioning at 10% of what the rest of the walls are, then that has to be the area where you're going to drive the U value up. So
are you assuming a standard electrochromic makeup 40% window area at an R5 versus you're saying the rest of the wall should be an R50?
I'm saying that if you look at some of the technologies that exist out there, those would be approximate values. Yeah, getting to an R5 even is challenging in a 1-inch unit. I don't care what the makeup of the glass is. And the only gain that you get out of that by putting an electrochromic on it is a reduction in solar heat gain. That's it. It doesn't increase the U value or improve the U value at all. I keep saying increase, but understand, it's not improving the U or the R. It's just eliminating some SHGC. And that alone is not enough, because you've got to reduce the heat loss through the unit. And so
let me ask this then. In that case, and I'm going to go down, agreeing with that stance.
Okay.
You would be of the camp to say, we got to find a complete alternate to aluminum, because it's just not going to cut it. We need to be looking at more UPVC. We need to be looking at more fiberglass and alternate framing materials, because if we really forget VIG for 1 second, if we're not going to drive the center of glass down to R10, we need the whole window assembly to be better.
Right.
And the frame
and the reality is you've got to drive that COG R value to probably closer to 20 for it to offset the 7-6% that's aluminum framing, even with the best thermal breaks. But if you can drive it to that 20 number or above through the utilization of alternative glasses, whether they be VIG or multi-layers, or even the new thin triples that are not quite that high, but they're getting closer. You can probably get to a 12 or 14 with a thin triple right now, maybe higher. I haven't kept up with all of it right at where they're.
That's close. Yeah, about a 12. Yeah.
Yeah. And so when you look at those numbers and the way heat transfer occurs, it starts to make sense when you get up high teens, low 20s. Then the aluminum becomes insignificant. The aluminum framing becomes an insignificant element of that model because the percentage of area and the temperature differentials and the heat transfer through it, first off, it goes down, and second off, it as a percentage of the big picture, it's not enough. Let's put it that way.
So I guess we're talking about, today's reality where the majority of what's being built is crap. I don't want to say crap, but below what it should be. And even if we are meeting national building codes, that's the worst we can build legally. It's still not to the standards that you're building in, a Boston or Seattle or Toronto or Vancouver. That's not what's happening in Idaho. That's not what's happening in, whatever, Philadelphia. So
right, or your southern climates even. I mean, that's where the reduction in SHGC has the biggest impact in the Sun Belt, but you still have to control not only solar heat gain, but reflected loss and things of that nature. And that air conditioning factor, if it's working less, because you're able to keep that temperature differential separated by the medium, whatever it might be, whether it be a triple, whether it be a dual skin, or whether it be a VIG, whatever that is, once you can keep that temperature differential there, and then with the variety of low E's that exist, the spectrally selective low E's and so on, there's some real gains that can be had in both northern climates and southern climates. And so, you gotta, there's no one answer that fits all, in my opinion.
Yes, well, the two products or two facade types we're talking about, or glazing types we're talking about, electrochromic and VIG. Don't you think you got these two things in your toolkit, and one can crush it in climate zone 1 through 4, the other one can crush it in climate zone 5 through 7?
Probably it's a better comparison. That's a great approach to it. One of the things I've always said, figure out a way to put the two of them together, and you might have the closest thing to nirvana that we're going to get right now. Having been around it this long, like I said, the electrochromic was cool. The predictive aspect of electrochromic is cool. The introduction of having to run these wires, the low voltage wiring throughout the building, adds a layer of expense and time and durability that has to be considered. The evolution of VIG to where it is today is the biggest change, because you can't get anywhere near the U values and R values that you get with VIG with any other product that's made today.
Do you think existing building versus new construction, do you think one product is poised for one, the other product's poised for the other?
No question. Yeah, VIG is absolutely, when you look at well, I just use New York City because you're sitting there and you're around it a lot. You look at what's going on there, and the idea that these buildings have to come up to, what is it, local code 992?
Local law 97.
Yeah. 97. Yeah, local law 97. These buildings, they're not all going to get done, but a lot of them will get done. And Con Ed's investment in the idea of reduction of energy consumption and the money that comes with that. I'm just using that one market, which is sure big, but by comparison to the whole country, it's still just a small piece of it. But just there, the number of existing buildings that will benefit from moving towards VIG is huge. I think. Yeah, again, I do these things for my clients, whether they be building owners, whether they be consultants, whether they be manufacturers. When I'm asked that kind of question, I have to answer it as honestly as I can, which is, I think that the idea behind VIG is significantly more impactful on that side of the coin.
With electrochromic, and I know we've both seen the application in both existing and new. Do you really not optimize or get the most out of it in an existing building?
If you go into the idea of using electrochromic for a thermal and energy consumption improvement, I think that it probably, again, suits itself better to new construction because you can eliminate window coverings, because you can route the cabling unobstructed. You're not having to bore
Optimize the orientation of the
yeah,
facade.
and you're not boring holes through walls, in particular fire break walls and things of that nature that in some cases you end up having to do. Not that it's a bad thing and that the technology doesn't exist. It's just that it's an added element. And if it's an existing building, pretty good chance there's already window coverings there. So now you aren't even eliminating the expense. You may even be adding to it because if you want to get rid of them, they've got to be removed then.
Have you seen it done in reglaze applications or only window replacement?
I've not think about that. Have I seen? No, I have not seen it done in a true reglaze.
And could
And
that be possible? Could you drill through the existing frame?
you absolutely you can. Yes, yes. Um, when I say I haven't seen it in a reglaze, I've seen it done where the addition of the electrochromic occurred after the windows got replaced. Um, and then they went in and added some electrochromic glass. And in fact, it was in Chicago. And when I talked to all of the stakeholders in the job, they all acknowledged that was bass backwards. I mean,
It, and when you've seen it done effectively, granted, a lot of this was a little bit of a trial effort, and you've seen the evolution, especially aesthetically, of the item and how it looks while it's going through its tinting transition. Do you see it typically used throughout elevations or predominantly on the south elevation?
No, I mean, most of the projects I've been involved in, it was used on at least 3 out of 4 elevations. Because if you take it from the comfort standpoint, then you would like that tint, even if it be the low in the sky, where you can transition up or transition down, or the high in the sky. Morning sunlight, for instance, if it's transitioned before your floor full of computer geeks walk in and start working at their workstations, and they don't have to worry about adjusting the blinds. They're still connected to the natural environment, but yet the glare is gone before they even realize it's gone.
Do you have an issue with uniformity throughout the building, or is it somewhat accepted it's going to look a little different?
I personally, I don't, and the aesthetic of the change, I find it interesting, honestly. When I see a building transitioning, or a portion of an elevation, or a portion of a window, for me, that's interesting. But that's me. That's my aesthetic. I'm not sure how architects and designers feel about that. I have seen it used on buildings where I think it was not a great marriage of the aesthetics of the design and the aesthetics of the performance product. So there's always that. I mean, no question about it. Like you had asked earlier, where does it fit best? Airports are certainly a huge part of it. And it's simply because of the number, the mass, the amount of glass that there are typically in all of them. And the healthcare areas, because you can eliminate the interior window coverings, which are dust catchers and disease holders and all those things. So those are the two biggies. Will electrochromic ever become huge in the rental markets? I don't know. I mean, it's on a few buildings. There are some even in your backyard that have adopted it. There are some where they've adopted it and it didn't suit what they were trying to achieve. It's still there, it's still working. It just didn't get what they were looking for.
Do you think the technology, I mean, it's been 10 years. Do you think the technology is progressing along with the market demands?
No, but it's not for lack of effort. It's just that there's a slow evolution that has to occur there. The aesthetics of the product itself has improved significantly across the board. Again, this goes back to something you talked about before too, which is the marketplace. If you don't have some level of competitiveness in the marketplace, I also think that slows down that developmental evolution. And so with some of what's gone on in that market, yeah, I don't know. I mean, I think that the innovative side of it has slowed from where it was, let's just say in 2015 to 2020, leading into COVID. I think there was a lot more developmental stuff happening at that point.
So let's now go to what you're more focused on to sort of end the chapter in this discussion. And let me just flat out ask, why do we not see VIG everywhere in these energy code driven markets?
I think you will. I think that is the next big step. I think that you got to remember, there's no Section 8 spec right now for VIG. So as there didn't used to be a section for electrochromic. So when you go now switching over to VIG with no set spec, it has to be driven by the energy number and the building envelope calculations and the building modeling that's done for instance, on existing buildings, when you model it to see what is going to be the drop in energy consumption after the change. It's market adoption, and similarly, there needs to be this drive and this competitiveness to go forward.
So you think there will be a day where there's going to be a VIG spec and people can bid it competitively with their 5 to 7 vendors of choice?
Yes, I do. Down the road at some point, I believe that's going to happen. I think that the product will ultimately speak for itself going forward. There's just so many pluses to it, and in particular in that arena of not having to change out frames. You just think about if you just reglaze a building instead of putting replacement windows or a replacement curtain wall on, it's probably, I would say the reduction in that change out is probably 60 to 70% in terms of the expense. And so when you see that, I think that's going to drive it. I think as the driving forces in the consultant marketplace, as they adopt it and go forward with it, as the larger developers start looking at it, the relateds and people of that nature, you're going to see, and especially after they get one job and they realize significant cost savings in their operating costs. And then
do you think we'll break through this sort of prescriptive 5x8 or 40 square foot limitation?
The way glass has gone, yeah, I mean, it will, but there are issues with anything in terms of application, the manufacturing of the products, I mean, even if you look at what's out there right now in VIG, it's driven by some size limitations, some shape limitations, things of that nature. And that'll all need to evolve. But right now, I'm excited about it. And I think I told you this when we spoke early on. I really feel like vacuum insulated glass is the most significant, more so than electrochromic even, in terms of a breakthrough product since Low E in the 70s, and then its real development and advancing in the 80s and 90s. But yeah, just no question about that in my mind. But again, there's a lot to be proven, and you've got architects who now want, they want wider span between the mullions. They want larger span between the floors. And so that will at some point drive, like it always has. I mean, jumbo glass, bent glass, a lot of these things didn't exist 25 years ago, so it's a reaction. So that I think it'll be there.
Well, I appreciate you coming on, Bob. It was fun hearing your perspective, and I commend you for always, because it's not easy seeing how quickly or slowly this industry progresses, but always sort of being at the front end of trying to push what's next. And
I just like the new. I do enjoy the new things. I do enjoy having the ability to talk to people and hear what it is they want and where they want to go with it. I mean, there's so many things I've gotten involved in. And as you know about me, I've been involved in a lot of litigation work through the years as well. And usually it's because people either weren't honest, didn't use the right product, or failed miserably in their execution. So from where I sit, what I try to do is demystify the the products and try to risk manage them as much as you can on the front end. But, because remember, a lot of litigation you see is failed to meet expectations, not failure to do what it can do, but failure to meet the expectation of the other party. So yeah, I mean, and tort will exist. There's no way it's going away. I mean, that's the world we live in, unfortunately.
Yeah.
So
Well, thank you for demystifying. Thanks for educating us, and I look
my
forward to catching
pleasure.
up soon.
My pleasure. We'll keep in touch, and I
All right.
appreciate what you're doing, by the way.
Of course.
Your posts are absolutely illuminating to a lot of people. So, and keep training your wife, because I've been trying.
Thanks, Bob. We'll talk soon.
Take care. It's great
Bye.
to see you, Adrian. Thanks.